Hi, I'm Dr. Eugene O'Loughlin and welcome to this course on problem-solving techniques. In this lesson, we're going to learn about use cases. So our objectives at the end of this lesson, you should be able to do the following. First of all, define what is meant by a use case. We're going to learn how to create use cases to model business systems, and then apply use cases to determine what a system can do for its users. We're going to use actors as outside entities that interact with a system. And finally, we're going to use simple language and templates to create a use case. Now, use cases are part of our Section 5, resource planning in our curriculum. And in this section, we can see that use cases is one of 3 resource planning problem-solving techniques. So let's, as always, begin with an inspirational quote. This one comes from Jesse James Garrett, a user experience designer. And he once wrote, "User-centered design means understanding what your users need, how they think, and how they behave, and incorporating that understanding into every aspect of your process." So Jesse James Garrett is teaching us here that user experience, the user-centered design is really, really important. So what is a use case? Well, in a use case, the role of the users of a business system is vitally important in our problem-solving efforts. So we want to concentrate on the users. It's primarily a tool for modeling software systems. In fact, they are created by the guy you see here, Dr. Ivar Jakobsen, a Swedish computer scientist, is credited with as the first person to create use cases. They can also be used for any kind of business modeling where there are requirements of the customer or the user. They need to be established. Now, use cases, what are they? They represent a series of interactions between an outside entity, and we'll see in a moment what that is, and a system, which ends by providing business value. So it's a simple tool that examines a system by expressing the interactions between the system and the environment. In other words, what goes in and what comes out. So it's a variation on the input process output model. Now, in the book Zen and the Art of Motorcycle Maintenance, Robert Pirsig, the author, uses historical terms to describe differing views of a motorcycle. You see the two of them here, the classic view and the romantic view. Now, here's me showing off on Route 66 in the desert in America on a bike, and I can see this bike in 2 ways. I can see the classic view sees a motorcycle in terms of its subsystems, the powertrain, the engine, braking, steering, safety, and so on. The romantic view sees the motorcycle as what it can do for the rider: speed up, slow down, weave through traffic, avoid accidents, and so on. So each view sees exactly the same motorcycle, but they see it from a much different perspective. So use cases see the system from the romantic view. So what can it do? So we're not concerned at all about, in the case of a motorcycle, the engine, handlebars, seats, and so on. We're only concerned with what the system can do for the user. And this in turn then makes them extremely effective for conveying information to users. We will see that in action in a moment. So use cases make use of what we call actors, and an actor is an outside entity that interacts with a system. Now, it's very often people, but not always. So the actor is the initiator of all interactions, something outside the application. Actors can be people, as I said, but also other systems, or something more abstract, such as a specific date and time that would trigger or initiate an interaction. Now, before we write some use cases, there are some do's and don'ts that we need to take account of. We want to remove implementation-specific language. So, for example, the first example here that we see is we don't write "the clerk pushes the OK button." What we should do is write "the clerk signifies the completion of the transaction." And the reason we do that is we remove the assumption that there is a user interface button. Now, it may end up that there would be an OK button in the system, but at this stage, we don't need to have implementation-specific language like that. Let's take a look at the second example. We don't write "the account holder folds the envelope with the cash or check and deposit slip and places it inside the slot on the automatic teller machine ATM." So we shouldn't write that because it's got implementation-specific language in it. We should write in turn "the account holder provides a deposit, including cash, check, and deposit summary data." And the assumptions that are removed then is that an envelope will be used, that there will be a deposit slip, that there is a slot, or even an ATM. And the last example here is a little bit more elaborate. We don't write something like, the customers use the mouse to click on their part selection for the zip code they specified in the pull-down box, and then click on the hyperlink to access the order finalization web page. We should write it much simpler, as follows. The customer chooses a part from a list of available parts in the specified zip code. And you're removing implementation-specific language such as the assumptions that there will be a mouse click, pull-down menu, hyperlink, web page, or navigation from one page to another. So we've got to try and keep it simple, but we also want to keep out the implementation-specific stuff. We're only concerned about what we can do. The implementation-specific information becomes important later on when somebody goes to build the system, but right now we're only concerned how the user interacts with the system. So when we're writing use cases, there's two parts to really. The first is the use case diagram, summarizing all the use cases in the scenario, and the second part then is writing the use case for each item. So the key to writing good use cases is to, first of all, identify the actors and the actual use cases themselves. Draw a use case diagram, we'll see an example in a moment, and then write up the use cases in simple language using a template, and remember to remove the implementation-specific language. So simplest use case here is for somebody to access a web page. We write that in an ellipse like this and put the title of the use case in the ellipse. And then we have in this case here one user who's going to access the web page. So that's how we would, so we have a use case here and we have one actor called a user in this case. So we take that diagram now and we want to be able to draw up the use case. Now the basic components of the use cases as shown in this template on the right hand side. And we have two parts to it here. We have the use case components, and then we have a description for each of those components. So let's take a look at these. We first of all have got to give the use case a unique name. Secondly, identify the actor or actors that interact with this particular system and the use case. So it could be a job title, but don't put down things like the name of a person. That's not needed at this stage. Are there any preconditions to the use case? So, for example, that the user would be logged into a system. Any fact that the proposed solution can assume to be true before the use case starts. Then the most important part is the basic flow of events, short description, non-implementation specific language, of course, showing the key basic flow events of the use case. So this can be a step-by-step procedure that the actors will take in order to interact with the system, and this is the most simple and correct path through the use case. Now there may be alternative paths or paths. This will show less common paths through the use case and will also deal with error handling. It will document some of the less common interactions between the actor and the system. The next component is the exceptions, if there are any, similar to the alternative path, but actually shows what happens when an error occurs. And then finally, the post conditions are any fact that the proposed solution can assume to be true after the use case ends. So this is the most basic description of a use case. You will come across more detailed ones with more components in them, but this is more than enough to get you started. So let's take a look at an example. Assume that a typical bank ATM, automatic teller machine, supports the following processes. Now, it will support many things, but I'm just picking out three here for the moment. That a customer uses the bank ATM for cash withdrawal, recording of all ATM transactions by a central computer, and finally, ATM maintenance by an engineer, which includes replenishing cash by a security agent. So you can see that there are three use cases here. So let's move on then and draw a diagram for that. The three use cases are withdraw cash, record transactions, and maintain the ATM. And we can see then we've put the users, the entities or actors on the outside. So I've got my customer on the left, and the customer only interacts with the withdraw cash use case. The customer does not record transactions and their customer does not maintain the ATM, so there's no lines from the customer to those. And typically we would use a stick person diagram like this one here to represent the customer. But the withdraw cash, we also know that the central computer, even though it's a computer, we still typically use stick persons to indicate the user here. The central computer interacts with withdraw cash and record transactions. And we also have them, but it does not get involved with the maintenance of the ATM. We can see that the other actors, engineers and securities, interact with maintain ATM. They don't interact with the withdraw cash or the record transactions. So we can see the different three use cases, four entities, and which actors interact with which use case. And once we've identified all of these actors and our use cases in our diagram, it's time to write up each individual use case. So we've got 3 here, so let's take a look at the 3 use cases. So the first of these is withdraw cash. And I'm using the same template I described a few moments ago. We've got a name, withdraw cash. We list the actor or actors, so we can see from our diagram that there are 2 actors interacting with the withdraw cash use case. The preconditions are the customer must have a valid ATM card, of course. And then we've got our basic flow of events. So a simple description of what goes on when you withdraw cash. You specify if a receipt is required. Step 2, enter the amount of cash to withdraw. Step 3, the machine checks with the central computer that the customer has sufficient cash on account to make the withdrawal. Step 4, cash is dispensed to the customer. Step 5, a receipt is dispensed to the customer if they indicated that they wanted one in step 1. So that's the basic flow of events, and we've all done this with a cash machine. Now, alternative paths through the process are as follows. So if the customer doesn't want a receipt, what happens? If the customer does not have enough cash on account to support the withdrawal, what happens? The link between the ATM and the central computer is broken. It doesn't happen very often, but I'm sure sometimes it does. The customer can cancel the transaction at any time. What happens? And the customer forgets to take the dispensed cash, something which I've actually done myself. Now, the exceptions are, these describe what happens when the errors do occur. So the following exceptions may occur in this use case. The customer incorrects an incorrect PIN number, and the system displays an error message, and the customer has a chance to re-enter the number. If the customer enters an amount of cash that is over the daily limit for the account holders, the system will display a message, and the customer re-enters an amount. Or alternatively, if the customer enters an amount of cash that is over their own balance, the system displays an error, and the customer re-enters an amount. In this case here, the post condition is that the customer account is updated by a central computer. So I recommend, I've gone through that fairly quickly, I recommend that you pause the video and examine and reread this case study. Now the second use case, I won't go through it in detail, this is the one where we record transactions in the center, and we can see it has 2 actors, just one actor at the central computer, and that's indicated here. We've got the preconditions, our basic flow of events, what are the alternative paths, are there exceptions, and what are the post conditions. Again, I recommend you pause the video to examine and analyze this use case. And the third use case in our case study here is the maintain ATM. You can see that it's got 2 actors, the engineer and the security agent, and that's indicated here. We've also list the basic flow of events, alternative paths, once again exceptions, and in this case there are no post conditions. Again, I recommend that you pause the video here and to read and examine the description of this use case. So once you have the use case template, it's a good starting point. And in our assignment for this particular lesson, I'm providing you with a template similar to the one we've just been looking at. And I'm going to look at the following scenario where a bookshop wants to set up an online ordering system where people can purchase books and so on. And I'm going to start you off here by giving you the 4 high-level use cases for this scenario. The first one is browse books, second is purchase a book, then we have checkout, and finally register a new customer. And as I say, the template is provided for that. So you get an opportunity to practice use cases in the assignment. So in summary, a use case is primarily a tool for modeling software systems. It's a simple tool that examines a system by expressing the interactions between the system and its environment. Very importantly, remember that use cases are concerned only with what the system can do for the users. Other items will come at a later stage, but in a use case, what can the system do? And finally, we ask you to write the use cases in simple language using non-implementation specific language. So that's how use cases can be used as a problem-solving technique. I hope you found this lesson useful.